Hello, this recording will cover a general purpose I/O input circuits on an Arduino with ATmega 328 chip using AVR Assembly. We're going to be setting up a circuit similar to the one we see here in the circuit simulator. We need to set our pin direction register. We have to clear it low to set input mode on our pin. And then we want to leave, in this example, we want to leave the port register cleared low to disengage the pull-up to leave the pin in high impedance or floating. Externally, we'll have a 5-volt source that will draw from the Arduino through a switch. When the switch is open, the pin should read low, and we'll implement a simple pull down with a 1K ohm resistor to keep any stray voltage from coming in and changing the value of the pin. When the switch is closed, the external 5-volt source will run through the switch and into the input general purpose I/O to drive the pin register high. So next we'll be setting up this circuit on our Arduino and then setting up a project for it. So here on the breadboard, I'm going to be setting up a circuit. I've just got a couple of components. I've got a little red LED. We're going to use that to show when we get input by driving this pin, this LED high, or turning the LED on when we receive input. I've got a little push button switch that I'm going to try to implement, a little momentary push button switch, and we'll use that to detect our input. I've got a 220 ohm resistor that I'll be using for the LED to protect the LED. And then I have some 1K ohm resistors. I'll pull one of these off to use for the pull-up circuit. And then just a couple of wires that I'll use to set up the circuit. I've zoomed into the breadboard so that hopefully we can see where I'm putting components. I'm just using a reference around these numbers, and I'll make a decision on which actual pins we're going to use on the board after I get the components put on. I just want to set up the external part of the circuit. I'm going to start by putting my push button, and you can see on the push button it has these clawed feet at the bottom of it, and they sort of point towards each other on either side of the button. And I want those to grip around the ravine in the middle of the breadboard. So I'm going to put those somewhere so that they grip into a couple of rows. So I'm going to have one I'm just going to kind of snap it in there. So I have one leg here in terminal 15, and then I have another leg in terminal 17. So that'll represent my circuit going into the switch and coming out. So I'm going to put the part that's going to connect to the breadboard as a data wire for detecting input. I'm going to put that here in row 15. I'm going to put that up a little bit higher in the middle of terminal 15. I'm going to put a red wire here on terminal 17. That will represent the external voltage source. And I'll show where I'm going to connect that onto the Arduino soon. But we'll see that I'm going to have voltage coming through this red wire on terminal 17 into the switch, and then out of the switch into this orange wire that I'll run to a GPIO pin. Now, to make this pull-down circuit, I just need to connect this side here with the data wire. I need to connect this terminal 15 to the ground terminal, and then I can run this ground terminal to the ground on the Arduino, and that will give me a pull down to pull any spare voltage that might try to get onto this orange wire down to ground. So I'm just going to take one of these resistors, 1K ohm resistors. And remember, they don't have any polarity, but I'm going to insert one end of the resistor into terminal 15 and then put it into the ground rail. It doesn't really matter where in the ground rail it goes. So I've zoomed out a little bit so we can see my 1K ohm resistor is going into this inner ground rail of my breadboard, and then going into this first hole in terminal 15. My orange wire is in the middle hole here on terminal 15, and then one pole of my switch is in terminal 15 right here by the ravine. And then my power wire is going into terminal 17, and my other pole of my switch is also in terminal 17. To set up my output indication, I'm going to be using a red LED. I want the red LED to be somewhere on the breadboard away from this part of the circuit. So I'm just going to put it, so that the anode, the positive side, is facing downwards. And I'm going to use here, just for reference, row 22 for the anode and row 20 for the cathode, or the negative side. Now I'm going to connect my 220 ohm resistor into terminal 20, the cathode side of the resistor, and put that into the ground rail as well. And so my LED, the cathode or negative is in terminal 20, and the resistor is in terminal 20. So they're connected together, and then the other side of the resistor is going into the ground rail here. And then I'm just going to connect another colored wire to represent the data output to the LED. I'm just going to put it in terminal 22, where the anode or positive side of the LED is. And that way I can send voltage to light the LED. So voltage will travel through the green wire from an input port, or from a GPIO on the board, through the green wire, through the LED, and then through the resistor back to ground. So I will need one common ground in my breadboard. So I'm going to use a black wire, and I just need to connect it anywhere in this ground rail. And I'll be able to connect that to the ground on the Arduino. Navigating out to the Arduino CC site, I can go to Documentation, the Arduino New Docs, and then scroll down to find the Arduino UNO R3. And then I can launch the pinout diagram from here. And it shows me pictorially what the pins are on the board that I can choose from. And so here we have D0 through D13. These are not port D, these are just pin numbers. These are the pin numbers that we would see physically on the Arduino. But then the actual ports are listed here, port D0, port D1, starting from the bottom up through port D7. Then we start with port B0 up through port B5. Remember, port B5 is also tied to this built-in LED. So let's just choose some pins in here to use. Let's use port B pin 0 for our input and port D pin, let's give ourselves some space, port D pin 6 for the output to the LED. So port B pin 0 is D8 on our board, and port B pin 6 is D6 on our board. So I've pulled up Notepad and made myself some notes here so I know my input is going to be on port B pin 0, which is pin D8 on the Arduino, and my output will be on port D7, which is D7 on the Arduino. I'm going to hide the pinout diagram now, and looking back at my circuit simulator, I am going to set up this circuit so that I am going to source 5 volts from the Arduino externally through my switch. So I need to set up my input GPIO as input with high impedance. So that's port B, port B0, pin 0. So this is telling me I need to set the data direction register. So I'm going to need to set DDRB. I'm going to need to set that for DDB0, and I need to set that to a 0 for input. I need to make sure the port register, the output register, is a 0 for high impedance. So that'll be on port B for PB0. I need to make that a 0 for high impedance. And then I will read input on the pin register, which will be pin B, pin B0. 0 or switch open will equal 0, and closed will equal a 1 in the pin register for pin B0. These are just some good notes that I can use. For my output, which is not really reflected in this, I'll need to set the direction register for pin B7, DDRD for port D, DD D7. I'll need to set it to a 1 for output. And then I can make sure the LED is not getting voltage by making sure the port register is off or cleared. So I'll want to make sure that on port D, PD7 is equal to a 0 for LED off. And then once I get input, I'll want to make PD7 a 1 for LED on. What we're going to attempt to do is, while the pin is high, then we'll make the LED high. When the pin is low, we'll make the LED low. So we're going to set that up in our code. Right now, let's go back to our circuit and wire this for our the rest of our circuit. So I'm going to start with the source for the external 5-volt source. Zooming in on the Arduino, I can see over here there's a 3.3 volt source and a 5 volt source. So I want that 5 volt source. So I'm going to take my red LED, which is representing my voltage, and put that into that 5 volt source on the Arduino. And so now I'll be sourcing 5 volts from the Arduino to one side of my switch. Now I want the input side that's going to read when the switch is closed, which is my orange wire. I want it to go into pin 8 or D8, which is port B pin 0 on my Arduino. I've put that wire, the orange wire, into pin 8 here on the Arduino. And then my green wire, which is going to be my output, it needs to go into D7, which is port D. Oh, I said I was going to do 6, but we'll just do 7. That's fine. So it'll be right next to the orange wire on pin 7 on the Arduino. Right here, pin 7. And that's port D, pin 7. And that will run out to the anode side of my LED here in terminal 22. And when I do make it high, it'll send voltage through the LED to the cathode side and then through the resistor, the 220 ohm resistor, to the ground rail. Now the only thing I don't have connected is this ground wire, and I will be putting it into, I can either put it in this ground pin here on the Arduino, or over by the power, I have 2 grounds right next to each other that I can use. So either one of those is fine. I'll probably just use this ground right here, but I don't want to put that into the ground yet until after I've programmed the board, because I don't want the external circuit connected while the program is being loaded onto the Arduino. So I'm going to stop now with the circuit and start to work on the code. So I'm going to start a new project in Microchip Studio. And it will be an AVR assembler, and I'm going to call it input high impedance. And I want that to be in my projects folder in documents. And I don't want to create a directory for the solution. I want the solution and the project to share the same directory. All right, so we're using the AT Mega 328 without the P on it. Okay, I've got a new project up. I'm going to add my purpose. Demonstrate GPIO input with high impedance. All right, and I'm going to get rid of everything else. I'm going to create my main and my end main labels with an R jump to end main. All right, probably won't need that, but we'll leave it there just in case. All right, so first thing to look at, we said we would set up our input on port B pin 0, so we need to set our direction register for pin DDB0 to a 0 for input. So let's sorry, sometimes this thing jumps around on me. Configure GPIO. All right, so we want to clear our DD, that should be tabbed in one, sorry. Clear our DDR register for, once again, that was going to be, for input, it was going to be port B pin 0. So our DDR-B register for DDB0, and that's going to make B0 input. Then we want to set port B, the output register, PB0 to 0 to put it in high impedance. So to make it 0, we can clear it. Port B, PB0, make B0 high impedance. Now we're not ready to start reading the pin, so we won't worry about this yet. Let's go ahead and set up our output on port D for D7. So to make it output, we need to make the direction high or a 1. So we can do an SBI for the data direction register for port D for data direction D7. And that will make D7 output. And then we just want to make sure, even though our board resets and makes everything 0, we want to show it. So we're going to go ahead and clear the output register, port D, for port D7. And this will make sure LED is off. All right, so I'm going to tab this in so we can see we're configuring our GPIO registers. We've set port D pin 0 as input and made sure it was in high impedance by clearing the output register. We've set the direction register for port D pin 7 to output by putting a 1 in that pin and then clearing the port D pin 7 so that the LED on there is off. Now we want to set up some type of a loop where we can look for a high signal on our pin, because once again, our pin should read low while the switch is open. When the switch is closed or the push button is pushed, our pin should read high, and we want to make sure that our LED is high. And then when our pin is released, we would want to make our LED low again. So I am going to start a loop down here by creating a label that we can jump back to. So we'll do this, let's call this our scan input loop. Now, what we're going to do is I'm actually going to move this well, before I move it, let's put in what we're going to look for. We want to look for the pin to be low. What I've done is I've added some pseudocode for what we want to do. So if the pin is low, we want to clear PD7, which we're doing here, to turn the LED off. Else we want to set PD7 to turn the LED on. So clear PD7 to turn LED off, or set PD7 to turn the LED on. Right? So the instruction here we know would be CDI port D PD7. And that would clear PD7 to turn it off. Here, if we had an SPI on port D PD7, that would set the PD7 to turn the LED on. We don't want to do this if the pin is high. So if the pin is low, we want to do this. So if the pin is high, we don't want to do this. So we can skip if bit in IO, skip, if skip bit in IO set or high for our input pin, which is on pin D, and for pin D7. So if pin D7 is high, we will skip this clear. And then we don't want to do this if pin D7 is low. So we only want to set this if pin D7 is high. So we're going to do another skip bit clear pin D7. And then here we want to jump back to scan input. So every time we enter this loop, if pin D7 is high, we will skip this clear, confirm that it's not cleared, we'd set the output pin, and I've made a mistake in that we should be checking port B, pin 0 for input, B0. Our input pin is B0, our output is B7. So once again, this would be B and B0. All right, so if pin B0 is high, we won't clear D7. If pin B0 is low, we won't set D7. So we can go back through this and say, if B0 is high, then the switch has been closed and the 5-volt source is driving the pin high, and we want to light our LED. So if it's high, we will skip this instruction. Here it's not going to be low because we've already determined it's high, so we won't skip this and we'll turn on the LED. And then our jump back up. If the pin is set, we will skip still set. In other words, the button is still being pressed, then we'll skip this again. If the button has been released at this point, then we won't skip this and we'll clear port D pin 7 to turn the LED off. And if it's still cleared, we will skip this instruction and our jump back. So let's see how this is going to work. I'm going to do a build. Right, and now I need to bring up Device Manager. All right, and then very important, over here on the circuit, I don't have the ground wire connected. I'm going to go ahead and program the Arduino. So I've got my USB cable in. I'm going to connect it to my computer. And I see it came up here on COM6. And if I look in here in Microchip Studio to see, have I already set up a COM6 for programming? I have. So I'm just going to click that. If you haven't done the external tools, view the other video on output, GPIO output to blink an LED, and we go through the programming there. So I'm just going to run the programmer. We get some lights on the LED on the Arduino as it's programming, and we see that AVR dude ran. We don't see any errors here in this last part, and we see that it is done. So our board has been programmed. I'm now going to plug the black wire from my ground rail into the ground pin, which is pin 14 on the Arduino. So my circuit is now grounded, and if I push my LED and hold it, my red, or push my push button and hold it, my red LED is lit up. If I release it, the LED goes back off. If I hold it, my LED will go on, release it, it'll go off. So we know we're getting input by sourcing voltage from the red wire from the Arduino, 5 volt, and we're running that through the red wire to terminal 17 of the board, which is going into one terminal, one post of the switch. The other side of the switch is coming out to the orange wire, which is going into our port B pin 0 or D8 on the board. And then we also have a resistor in the same terminal 15 that's going to the ground rail to act as our pull-down circuit. So once again, we're mimicking this circuit in this simulator. So while the switch is open, any spare voltage is going across this 1K resistor to the ground rail. And then we have the black wire in the ground rail, which is coming over to the ground on the Arduino. Then when the button is pushed, current is allowed to run through the red wire, through the switch, and then back into the board through the orange wire, which has less resistance than the 1K ohm resistor. So that's why we get voltage source at our pin, and we determine that the pin goes from a 0 to a 1 on our input pin. And then we source voltage out the green wire into the anode of the LED through to the cathode to our 220 ohm resistor, which then connects that to the ground rail and back to the black wire in the ground rail, which is going to the ground. All right, so that completes our circuit for GPIO with high impedance. Just to review the code again, we configured our input pin on port B, pin 0, by clearing it to make the direction input. And then we cleared the port B register here to disconnect the internal 5 volts pull-up circuit, leaving the pin floating so we can detect input from external. Then for our output for the LED, we set the direction of port B pin D7. We set it high to make the direction output, and then cleared port B output register for D7 to make sure the LED was off. Then we set up a simple loop where if the pin was low, so if it is low, we don't skip and we clear pin D7 low to turn the LED off. If the input pin is cleared, we skip this, setting it high, and jump back up. If the pin reads a high, meaning the button has been pushed and voltage is going into the pin, then we skip the clear, and since it's not the input B0 is high, we don't skip the set, and we end up setting the LED on. So it's just a quick trick using the 2 skips to set up the scenarios we want so that we do end up either setting or clearing the output pin for the LED based off what the current state of the pin register is. So it may take a little bit of time looking at that, but hopefully that'll start to make sense for you. There are obviously other ways to do